Why are neural networks so crucial in unsupervised learning? To answer this question, we're going to delve into the fascinating world of autoencoders, a type of neural network architecture that plays a key role in unsupervised learning. First, let's familiarize ourselves with the components of autoencoders. The first part is the encoder. This is the component that takes the input data and compresses it into a lower dimensional representation. It's a bit like packing for a trip. You have to decide what's essential and what can be left behind. The encoder is adept at doing this, taking vast amounts of information and distilling it down into its most crucial elements. Next, we have the latent space. This is the compressed or encoded form of the input data. It's like your suitcase after you've packed, a condensed version of your wardrobe. The size of the latent space, or the number of neurons in the bottleneck layer of the encoder, determines how much compression occurs. Just like with packing, a smaller suitcase might mean leaving some things behind. The final component is the decoder. This is where your packed suitcase gets unpacked. The decoder takes the compressed representation from the latent space and attempts to reconstruct the original input data. This reconstruction should closely resemble the original data, much like your clothes should still look like clothes after being unpacked from a suitcase. Training an autoencoder involves minimizing the reconstruction error. This is essentially a measure of how well the decoder can recreate the original input data from the compressed representation. It's like comparing your clothes before and after packing. The closer the match, the better the autoencoder. Autoencoders are invaluable tools in many applications. They're like the Swiss Army knives of unsupervised learning. They're frequently used for dimensionality reduction, helping to eliminate noise and redundancy in high-dimensional data. This can be incredibly useful for tasks such as image compression. Another application is anomaly detection. By training autoencoders on normal data, we can then evaluate how well they reconstruct new data instances. If a data point is reconstructed poorly, it may be an anomaly or outlier. Autoencoders also shine in feature learning. After training, the encoder part of the autoencoder can extract compact and informative representations of data, which can then be used as input for other machine learning tasks. Lastly, some autoencoders, such as variational autoencoders, are capable of generating new data points similar to the training data, making them useful for tasks like generating realistic images, text, or audio. So why are neural networks so important in unsupervised learning? The answer lies in autoencoders. They're an elegant solution for many unsupervised learning tasks, providing a powerful tool for dimensionality reduction, anomaly detection, feature learning, and generative modeling. In the vast landscape of unsupervised learning, autoencoders are indeed a beacon of light.